Welcome to the very first AI Academy after the summer break. Today we are going to cover the very exciting topic of AI-based fact-checking. For those of you attending the AI Academy for the very first time, don't worry, we got you covered. So, the AI Academy is an info series which is realized by the very kind support of Hessian AI Startup Rising, and the EDIT program. EDIT stands for Enabling Digital Innovation and Technology in Hessen. It's an exchange format meant to bring together people from science and the industry perspective to change opinions and points of view coming from two different directions. So we got a very nice exchange format meant for AI experts, so AI beginners, but also meant for the curious. And we provide interesting perspectives. We take place at the end of the working day, and we are most of the time online and free of charge. This format usually takes place with nice irregularity, so round about every 2 months. Today, it is my great pleasure to host my very first AI Academy. I'm Severin and I will be your charming host today. However, I could not do this alone, so I'm very happy to have Mitali and Simon with me for the technical support. We are also thinking of Anna today, who previously hosted the AI Academy, and we are sending a lots of love over to her. All of us are working for Hessian AI, so let me briefly introduce you to Hessian AI. Hessian AI is a research and innovation center, which is located, much to everyone's surprise, in the lovely state of Hessen. So we are located in Darmstadt and belong to the Technical University of Darmstadt. However, we are much more than the Technical University of Darmstadt, as we have over 70 members from 13 different universities all over from Hessen, and we are funded by 3 Hessian ministries. As Research and Innovation Center, of course, we are conducting groundbreaking AI research. However, it is also one of our aims to bridge the gap of science over to the society and to the industry. So being very close to research, we also are very close to innovations, and those ideas are the ones we want to support. So we can also support AI startups from the very first idea up to the market scaling behavior. We're interested in bridging the gap, so knowledge transfer is also one of our very important tasks, and we conduct formats, for example, like the AI industry, the AI Academy and the Industry Challenge. However, we also provide AI infrastructure and services, and we have our supercomputer clusters 42 and 43 introduced this year. However, back to the science part, let us dive in. So we are currently living in the era in which fake news are unfortunately no longer fake news itself. So we experience an era of rampant dis and misinformation. So we need reliable fact-checking in our daily life. Basically, we need it to protect the public disclosure and democratic institutions. And this is what our today's speaker is focusing on in detail. He will reflect on common types of fake news and introduce the current state of IA-based fact-checking. Ladies and gentlemen, let us all welcome Mark Rothermel. Hey Mark, I have prepared a short CV for you. Let me see how very well I do, how much justice I can do for you today. So Mark is currently a PhD student at the Technical University of Darmstadt, and he joined the multimodal AI lab in 2023 under the supervision of Anna Rohrbach. He already successfully developed a system on fact-checking, and today even developed it further. And beside that fact, he also holds a bachelor and master degree in computational sciences, and he also has a bachelor degree in mathematics. Beside his scientific interests, which also include reinforcement learning and explainable AI, he's a passionate photographer. So, hello, Mark. Lovely that you join us today. How are you?
Hi, Zarina. Thank you very much for the introduction. And yeah, I'm very good, and I hope you're also very fine.
Yeah, I'm a little nervous, but I'm also very excited for the science we are going to hear today. And as I already warned you before, we have a small ritual here in the AI Academy. And this is some kind of personal item that you would relate to your research. So I'm very excited what you brought us today.
You already teasered it a bit. I brought my
Really?
camera because, as you said, I'm a passionate photographer, and I'm photographing with a Canon EOS M6 Mark II, which is a mirrorless camera, and taking very nice photos. Also, my profile photos are mostly taken with this camera, actually.
Oh, lovely. So I love that this is actually a coincidence. I did you are already sharing the same name as your hobby and
Yeah.
your personal item. So that from my side, if there's nothing else to discuss now, I'm really excited for the science part. So feel free to share your screen. And then all that's left for me to do is to say, Veritas ex machina. I'm unfortunately a French person, so not the Latin part. But the current state of AI-based fact-checking, the stage is yours.
Thank you, Serena. Yeah, you said it, veritas ex machina. So I'm also a French guy, not a Latin guy, but as far as I know, this means truth coming from the machine. And this is really the topic of today, using technology, using AI to fact check information and yeah, developing the truth. And today it's mostly about the current state of AI-based fact-checking methods. But first, before going into the methods of how to fact-check, I would like to bring us all on the same page and look at some examples of fake news and misinformation first. And this comes mostly on social media. Here we have an example from the recent Israel and Iran war. Here, the poster, the author claims like that Tel Aviv was hit with missiles and looks then like this, but actually it turns out that this is entirely deep fake. AI generated a deep fake and just added with some music and posted on the web. Yeah, this never happened. Actually, there was by far no such destruction at all in Tel Aviv. Here's another video showing like a plane crash close to Brandenburger Tor. That's a video which I actually created by myself with the help of Sora, and grabbed some audio from some random Telegram video of some very different event, and also looks very authentic on the first glimpse. Here is a video which actually contains real footage, real videos, which are not generated or not altered, and they are they are claimed to show like results of the earthquake of in Russia, which happened recently a few weeks ago. But actually, these videos are all from different unrelated events. So this is not okay. So this actually looks deepfake generated, but. Otherwise, this has nothing to do with the earthquake in Russia, and is yeah, entirely made up in this context. Also here another video showing actually an entirely so the claim here is that the London police arrested an Israeli officer and her husband following accusations, whatever. But this is actually an entirely staged video made for entertainment and not for yeah, and not showing such a scene. Yeah, and there's also some kinds of scam. Like here is a game posted on Facebook where people can win some prizes by answering a dumb question, which is also remotely some kind of fake news because this account does not represent actually this market chain called Action. Um, and there's also here in this post, this claim, the author claims that Trump institutes a military draft for everyone who has an Ukraine flag in their profile picture. Um, but this information actually originates from a page called the Babylon Bee, which is a satire page. And so satire, which originally is not meant to be fake news, it's just made for entertainment, sometimes also um, converges or translates into fake news because people misunderstand this information and then propagate it as and sell it as true news. Yeah. um, that is maybe a bit fun, but it also gets very serious, especially if we look at activities coming from Russia. For example, during the last elections in Germany, the general elections, Russia had a disinformation campaign called Storm 1516, which created web pages which looked like local news media, like this one here, Wochenrückblick aus München, where they published like entirely made up stories to harm the Democratic candidates and to support the AfD. And I also opened that website on here on Web Archive, and here you can see that they not just only have this generic image, but they also made actually a video of a doctor um, telling about the situation of what happened in the hospital where Mertz apparently like tried to do a suicide. Here they also show like images of the diagnosis and claiming that he would be emotionally unstable and where it was looking like this as evidence. So this is really high class made up disinformation coming in this case from Russia in the Storm 1516 campaign, and it also like reaches millions of people. Posts on social media featuring such this article reached 5 or 6 million people online, which is already very heavy. And and also the World Economic Forum identifies mis and disinformation as like one of the major threats or a serious global, the most serious global threat in the mid-term perspective, even before war and before climate change. So there's like very urgent need to do fact checking, and also there's not much help coming from the U.S. either with Musk or Trump or Meta, which actually recently stopped fact checking cooperation with fact checking organizations on their social media platforms, um, and all the fact checking organizations are yeah, left alone here. Um, let me yeah. There is the also the um, all the fact checking organizations, which are mostly like media houses, are organized on a global level through the IFCN, which is the International Fact Checking Network. Um, there are actually a lot of fact-checking organizations. However, they do not scale to the mass of fake news because fact-checking takes a long time. You need about like a whole working day to fact-check and to write an article for a single claim. And And that's why human fact-checking is not enough, and that's why we need automated fact-checking. I prepared a roadmap for today consisting of 4 modules. We will begin to look at the problem from a more analytic perspective, a more scientific perspective. What does it mean to fact check, and what's and what's the data? What does the data look like, also in terms of modalities? Then we will check out the methods which are out there before I go over our own fact-checking method, which we call DEFAME. And finally, we will cover the remaining open challenges in this field. Yeah, going into the problem. So, yeah, the goal is to automate multimodal fact-checking for my research. Multimodal fact-checking because images and videos actually have a huge impact on how people perceive the content. They increase engagement rates. They are more interesting. Images and videos also they have an effect as serving as evidence. So content featuring images and videos appear more credible. And the input is always a claim, which can be a combination of text and images or videos, or like any combination of that. And the goal is to design a fact-checking system which takes this claim as input and outputs the corresponding veracity of that claim. Meaning, like, could be supported, could be refuted, could be or the evidence which was gathered could be conflicting, or it could be also unknown. We should always have a category of that to abstain from a decision if there is no evidence or not sufficient evidence to judge the veracity. Yes, and looking at the modalities of fake news out there, there was a nice work called Amoeba by Dufour from last year, which actually went there and they analyzed all the claims which were fact-checked by fact-checking organizations. So they gathered them all and put them into a database and categorized which claims do contain videos, which claims do contain images, which claims to contain anything else. And they found that by the time of December 2023, about 50% of the claims fact-checked by fact-checking organizations, so the claims which are actually relevant, are video-based. So they contain, like, as a central part of the claim, they contain a video, which yeah, which is a main part of the claim. Images made up about 25% of the claims. Text-based claims, text-only claims were only about 21%. And then we have 4% cases of mixed claims, which means in total we have about 79% media-based claims. And that's also why multimodal fact-checking is very important, because the vast majority of claims actually features images and videos, which which cannot be handled through the text-only fact-checking. Also, they found that the share of videos is rising since like end of 2022. I don't know the reason, but sorry, yeah. So the videos is the orange line. I don't know the reason, but this trend probably also continues further, and therefore video fact-checking itself is getting also more important. Looking more closely to visual fake news, so videos and images, or in their case, Dufour et al., they looked at image-based claims. They found that 44% of the claims are manipulated context, which means that the image, which is part of the claim, the image itself is not manipulated. It's an actual pristine image coming from some other context. And the text, like the caption for that image, was changed to create a different context. This is what manipulated context means. 30% of the images itself contained only text within the image. So it was a pixel image containing text only. That's about a third of the cases. 8% were not really identifiable, and 13% of the images featured manipulated content, which means using Photoshop to change properties of the image, or remove some things, or add some things, or whatever. Only 5% of the images they analyzed were actually generated, so were deepfakes. But this was, recall, this was as of December 2023. So there is a likely, it's very likely that there are much more images by now, deepfake images right now. Here is also the timeline of the different kinds of visual fake news over time. And there we see that deepfakes, which is the red line, started to increase by the end of 2022, pretty like rapidly. But by the end of 2023, they were still not like the major kind of visual fake news. It might be now somewhere way above. We don't know exactly, because there was no new study on that yet. So, but we see reports that deepfakes are actually beginning to dominate this year, since like this summer. Some write even about the first AI war, which came with the Israel-Iran conflict 2 months ago, where photos like this were shared on social media. Like, this is actually clearly a deep fake. You can see that by looking at the people, which are like much smaller than this way too huge plane, or also the cars over here. Like the size relation really doesn't make any sense. But this image still was widely shared on social media, and it was claimed that this is a downed F-33 jet coming from the Israelis, and it was like shot down by the Iranians. Many people like really did not see that this is actually a deep fake. Even state media in Iran and also outside used other deep fakes to as evidence to tell that there were Israeli jets shot down from the air. EDMO also analyzed all this. EDMO is the European Digital Media Observatory, and also like they're like observing a lot of what's going on in the information space regarding fake news, and also like overseeing fact-checking organizations, and writing monthly briefs about these about the development of the situations. And they found like that for the first time, AI generated content leads the charge of false news. And not only not only them, but also Correctiv, also right, that KI fakes are on the rise, and even executives are more a target of deepfakes, which a report found. It's called the Ponemons Digital Executive Protection Report, which is from Economy, and even they start to like get attacked by these deepfakes. Yeah. Now let's look at the methods of fact checking. What we definitely should consider is, or other way, I would not recommend to use this for fact checking. This is Grok was introduced in March this year on X, and people start to use it for fact checking, like posts and claims, and uh, but it is actually only if you want to do it quick and dirty, then of course you can use Grok, but I can show you an example why it's not a good idea. Here, you can see a clearly AI generated image. For example, the plane here has a tail on its front part, which is like which doesn't make sense. Or also the cars are merged over here. It has lots of like non-logical parts in this image. So this is an AI generated image, but a user on X actually asked Grok to tell what this image shows and if it's real or not. And Grok said the image likely depicts the American Airlines plane fire at Denver International Airport on March 13th. The tick logo on the bottom right suggests it was shared on TikTok, supporting its authenticity. So it even thinks that because it was shared on TikTok, the authenticity is increased because of that. So that absolutely does not make that's absolutely not true. That's like the worst which could happen, and this is not the only incidents where Grok is telling, like itself is telling misinformation. This happens quite often, quite regularly, which is actually even amplifying misinformation frequently. And that is quite an issue regarding also the people's trust in such AI systems. And therefore, do not use Grok. There are other methods. um, on a like looking at the history briefly of how fact-checking methods evolved, like since the beginning of AI in this 20th century, multi-layered perceptrons, for example, were used to um, to classify images, which could potentially be used for fact checking, for example. Like this is like the very, very rudimentary kind of fact checking where you train an AI system beforehand on a very narrow task, and then to predict like a verdict out of that. These were like the early approaches. Semantic-based approaches started to be introduced when we were able to actually represent words as vectors, for example, which came from the word2vec a method. And this allowed us to, for example, compare a given claim with data which we have in a knowledge base, and use this to predict the verdict. Like for example, like looking at the entailment given a claim and the information given in the knowledge base. And also, these methods started to also come up with justifications for their predictions. So during that time, there emerged methods like so-called saliency maps, which are heat maps for images, highlighting regions of the image which are relevant for the decision for the verdict. Or highlighting parts of the text which are which have some certain sentiment, etc. So there are different approaches which can add information to justify the verdict, to make it more transparent, more explainable. And then, since the rise of LLMs, in this case, like since 2022, we are starting to get much more sophisticated with fact-checking methods. So, what so early LLM approaches only used the LLM itself to directly predict the verdict using the parametric knowledge, maybe using some fine tuning to improve it on specific topics or to update it on more recent data. But this is not enough because LLM knowledge is quickly outdated, especially for recent events that are happening. There we actually need we really need up-to-date information from the web, and that's why the parametric knowledge of the LM itself is not sufficient, and also knowledge bases like, say, Wikipedia or some database are not enough to do fact checking, and therefore it's super crucial to have access to the internet and to do web search and other forms of evidence retrieval, not only through the internet, but also through tools. You maybe recall from last talk, which was about LLM agents, which employ tools to execute specific tasks, for example, deepfake detection in this case here, or geolocation or whatever. Evidence retrieval is the like the most important and the most difficult subtask of fact checking. It's if you were able to do evidence retrieval successfully, so finding information to verify the claim, you already have done way more than half of the work. And evidence retrieval techniques, as I mentioned, are especially web search. So entering text into some search machine like Google and getting search results as text back. But also you can use image search, of course, to find visual evidence for a given event. Or you can also use reverse image search, which is especially important if you have visual parts in your claim and want to find other sources also featuring that visual information to check out if the image was actually from the same event, or or whether it was from a different event. Also very important, as I roughly mentioned, are deepfake detectors. Deepfake detectors can operate on different layers of analysis. Like very briefly, they can run on pixel level, where, for example, neighboring pixels are compared to a specific selected pixel and be classified by this, or on a semantic level where we verify like logical inconsistencies. Here on this image, Trump has 6 fingers in one hand, which is a clear sign of deepfake. Deepfake detection methods can also look at temporal inconsistencies in videos where we could, for example, see irregularities like these by looking at the eyebrows over time, or checking out the audio from a deepfake audio, or looking at the metadata of images. So the capture date, the location where it was captured, and also which camera was used for capturing the image. They all are supporting evidence for an image to be real. And also other important tools are the localization and identification of parts of an image. Here on the right, we see a video which was claimed to be captured in Syria, claiming that Israeli forces advanced into Syrian territory. Posted on March 5th. That was the claim, but geolocation would reveal that this was actually recorded in Jordan, and chronolocation, so finding the time when it was captured by doing reverse search, for example, reveals that it was captured some days before that, in February 27th. And you could also use identification of people to also have additional pointers of a source of that image. Yeah. On a very broad level, we see looking at the papers, like the number of papers released in the fact-checking domain, we luckily see a strong increase. The yellow line shows the fact-checking, general fact-checking papers overall, and the orange line those which are dealing with the automation of fact-checking. And the automation of fact-checking, also the share of the fact-checking papers overall is increasing as well. And the rise is especially happening since the invention of the transformer, so which is the foundation for large language models. And so there are actually a lot of fact-checking systems out there. We are by far not the only ones. There are many, many, many others. Here is like a list of the most important ones, which we also feature in our paper. And they have all different properties. I should skip them individually. So these systems either, for example, can handle multimodal claims, or they can handle multimodal evidence, or they do evidence retrieval or not. So all these systems, they only have like specific features, but none of them can handle them all. Especially like the multimodal claims and multimodal evidence retrieval are the two most important properties for a fact-checking system, and this is and there we can see all of them lack these features in combination at least. And we proposed DEFAME, which can handle them all, and has all these nice features. And yeah, to see how it works in detail, I will show you how it works. DEFAME, was developed by Toby and me, and we were supervised by Anna and Marcus at our lab. And it actually is a continuation of our method called InFact, which won a challenge last year in a text-only fact-checking competition where 21 teams engaged, and we won first place by far, actually. And and started our journey with fact-checking with that method. And but it was only text only. So we extended, InFact, to also support images and also to be more powerful, more flexible for also more complex claims. DEFAME on a high level works like this. It is a 6-stage multimodal large language model pipeline. It takes in the multimodal claim, which can consist of any combination of text and images, so it can be even multiple images. And it uses evidence retrieval through web search, through deepfake detection, and other tools to retrieve external knowledge. And what it does, it not only just returns a verdict about the claim being true or false, but it actually returns an entire report, which could look like this here. So the report contains the claim, which was originally inputted to DEFAME. Like, for example, here, image shows grounds covered with garbage after the end of Glastonbury Music Festival in 2015. And the report contains the actions which DEFAME performed, the evidence it retrieved, also the elaboration. So in this case, the reasoning DEFAME performed to assess the evidence and assess the claim and bring them together, and potentially more actions it performed, etc. And finally, of course, the verdict. whether the claim is true or false, and the justification, which is essentially a brief summary of what is in the report overall. So what are the main arguments for the claim being supported or refuted or whatever. And DEFAME is the first method that is able to handle both multimodal evidence and multimodal claims. And this report is also a nice feature, which also was not part of methods, other methods before. And maybe let's skip this slide briefly. And also that slide, because time is running. We evaluated DEFAME on also 4 different benchmarks that check different properties of the method, and showing them briefly. So the prior state of the art, which are shown with the blue lines, are surpassed by our method, by DEFAME, which is the orange line by far on all these 4 different benchmarks. And this makes our method actually the new state of the art in this field. Yeah, and yeah, this one we should also maybe skip. Looking at some examples, how this could, how the output of DEFAME looks like or a summary of that. Here we have another claim as input, namely this photo with the text: photograph shows people in China tearing down a 5G tower in an attempt to stop the spread of COVID-19 coronavirus disease, which is actually a wrong claim in the benchmark. And our system correctly identified this to be wrong, saying the image actually depicts a protest in Hong Kong where demonstrators attempted to pull down a smart lamp post due to concerns over surveillance unrelated to 5G or COVID-19. And then it also provides a list of links, of hyperlinks to the sources where it got the information from. So it provides a more accurate and also more transparent result, which users can use to further actually verify that content or the result. We also have a web demo developed where in a graphical user interface, users can actually even insert images and text and let it verify. But it's still in development, therefore we're waiting with the release of that. Finally, last module is that there's still a lot of open challenges left. The first thing, and this is the most important message maybe from this entire presentation, is that we are still not there yet. Even our system has still at most like about 80% accuracy. That also applies to many other systems, like all the other systems in the research area. So there's still this gap of 20% getting to the 100%, which is a bit frustrating. Yeah. Why is that the case? So we also now analyzed, of course, the errors which DEFAME made in its predictions. And from 119 analyzed failure cases, we identified like the top 4 root causes of these failures, and saw that the most prominent cause is label ambiguity, which means that the labels, the claims in the benchmark have, like being supported, being refuted, or whatever, they are sometimes too similar because one benchmark, for example, contains the label refuted and the label misleading, which means either the claim is false, or the claim is technically true, but it is misleading because it draws a wrong impression. This kind of ambiguity causes confusion in our system and creates wrong classifications. Also, DEFAME missed important evidence, which was, for example, only accessible on X, and X needs requires you to pay to get to access the contents through their API, which is expensive. And YouTube videos, for example, were also hard to access. The third most prominent error was were reasoning errors, meaning that DEFAME actually did logical mistakes during the chain of thought process of the LLM, and yeah, made these errors. And also one other another cause was that DEFAME sometimes committed to a verdict too early. So it technically could have done more iterations of fact checking before actually coming to before judging the veracity. So there was evidence, so there was still missing evidence, but it already committed to the verdict. There are also some other challenges which we have in our systems, namely, not in the systems, but in the kind we evaluate the systems. The benchmarks which we have the issue that they actually, it's a good property. Namely, the benchmarks contain real-world claims to be fact-checked by our by the fact-checking systems, and real-world claims have the issue, however, that they are publicly available from the web. These real-world claims are coming often from fact-checking articles published by fact-checking organizations. And these fact-checking articles are often part of the pre-training data of large language models. And since like almost all the fact-checking approaches in the science community use large language models today to do fact-checking, these models know the claims contained in the benchmarks. So these benchmarks are essentially leaked into the model's knowledge, and therefore the benchmarks are actually not suitable anymore to evaluate these models. Yeah, so each benchmark which you introduce will be soon out of date or soon be leaked at some point, and there we need another solution. Another issue is ambiguity in interpretation of claims. Given for this meme, for example, like contrasting lithium mining versus oil extraction. And here it's not entirely clear if it either claims that electric cars are environmentally worse than gasoline cars overall, or whether it maybe claims that lithium mining itself is environmentally worse than oil extraction, or maybe even something else. So this kind of raw content needs also be processed, and the claim needs to be extracted before we can do actual claim verification. We also need to handle irrelevant content somehow. For example, this nice post we don't want to fact check, and therefore we need to do some kind of triage to assess the check-worthiness of claims before actually doing fact checking, because we cannot fact check the entire web. We need to prioritize. I also mentioned inaccessible evidence. Facebook, for example, and Instagram, so Meta overall, they do not even provide API access to their contents. And And also fact-checking systems always will have the problem, like a huge disadvantage compared to humans. Human fact-checkers, for example, they can grab the phone and call some official and ask for their opinion or for their assessment of for some situation. They can dive into databases. They can log in or register into some services and use their abilities to continue their fact-checking work. But large language models, at least as of today, even a GPT-5 is not as far like that, and will require maybe some more development here. We also need to verify or evaluate the credibility of the sources we need, and this is also a missing component here. And we also need efficient methods where we compare claims that we found in the web to compare them to claims which we already know, which we already fact-checked in the past. And this claim matching procedure is currently also not. We're not there yet to have it at least efficiently. So it's either slow or it's inaccurate because it uses just semantic approaches. And that's one of the most important challenges, trust. Instances like Grok do not help fact-checking research and fact-checking systems because people see how badly Grok performs and then keep thinking that this also applies to future fact-checking methods, which is a strong issue here. So here we need to also repair a lot of trust. In the end, to conclude, DEFAME is the current state of the art in multimodal fact checking out there right now, but we are not there yet. There's still not the breakthrough. We need to employ systems like DEFAME on a large scale in public environments for people on social media, for example. So there's still some way to go. The challenges are both in the methodology, especially on the evidence retrieval side, and also in the measurement. So having a good benchmark to do meaningful evaluation here. Thank you a lot for listening, and now we have time for question and answers.
Thank you, Mike, for this very interesting talk. I'm still very much flattened by all the information you put in there. And since we also had very busy listeners, I would go to the chat first before I'm going to ask my questions that I have.
Sure, yeah.
So I'm going to read them also. Unfortunately, I stopped. I did not note down the slides from the very first part, but we have a question from Adrian. I think it was in the part where you still outlined the problem. And I think you talked about the fact-checking organization, and Adrian asked, what is the purpose of your organization? And when you said there are other sessions, what were they?
Okay, so the fact-checking organizations, this is just the human media organizations who are doing the manual fact-checking work. I myself or our research has nothing to do with them directly. It's just the problem that these organizations are not able to handle all the mass of fact-checking, all the mass of fake news in the web, and that's why we actually need automated fact-checking. That's the one question. And the second question was not entirely clear to me. You're talking about session. Could you repeat that?
The session, when you said that there are other sessions, what were they? Maybe we have still Adrian still online, and maybe he would like to phrase his question in other words.
Yeah, my question is, what is the purpose of your organization? I'm not really clear. And like, what is the purpose of today's session? What's the purpose of this? And what have you done in
Ah.
the past? And what are you doing in the future? I'm just not clear.
Mhm. So, so in the past, yeah, what we achieved was the DEFAME system, which we successfully which we successfully managed to get to the front of the fact-checking research and establishing a new state-of-the-art, which aggregates all the features which were very scattered, very fragmented on the fact-checking landscapes across different approaches, and we aggregate them into one single approach, which we call DEFAME, and achieving the best new results. The next steps actually now are as follows. I identified the lack of a good benchmark for evaluating such systems, and the main issue there was that these benchmarks get leaked, or their contents get leaked into large language models, parametric knowledge. So they know the claims already beforehand. So these benchmarks are not suitable anymore to do proper evaluation of such systems. And what we want to do is to, and this is the project we're working right now, to actually establish a new benchmark, a dynamically generated benchmark, which can retrieve fact-check claims from a given time window and use these claims to do proper evaluation of such systems with claims that are not leaked into the LLM's parametric knowledge. This is like the next logical step we are doing. And as soon as, or only when you have this proper benchmark to do meaningful evaluations, more meaningful evaluations, only then it makes sense to actually proceed with more powerful fact-checking systems. In other words, to further develop the DEFAME with more with adjustments and improvements to improve in the fact-checking domain overall. Yeah. So overall, the purpose here means that, or the purpose of the session was to tell, hey, first, there's urgent need for automated fact-checking systems. Second, we're by far not there yet to have them also ready for large-scale production. And third, to show what are the actual challenges that are open and where researchers can contribute to, or even also companies can contribute to advance this field. Yeah.
Does that answer your question?
Mhm.
Well, if we don't have any protests, I would go to the next question, which was asked by Maria. And she said the arrow to the internet is both-sided. What would you mean by that? I think that is linked to slide 35.
35. Let's check that out. That one over here. So the web search techniques. And the question was, did I get it right? Meaning that with both sides, meaning it can also reveal bad results, or what does that question mean?
Maria just typed, it's actually slide 44.
44. Oopsie. Let's go there.
That's my mistake, not up to you.
Yeah. Oh, 44 was
It's a slide with the picture where you show the claim, then the knowledge base, and then AI agent. And then,
yes, that one over here.
yeah, this one.
34. 34. Sorry. And now what do you mean by two-sided here?
So the arrow to the internet, I understand the arrow to the knowledge base, that it's both-sided, because you can also change the knowledge base by the new knowledge that AI agent gets. But what about internet?
Okay, yes, yeah. So here in this case, it means that the agent is actually interacting with the internet. So it submits search queries to a search engine, or submitting search or browsing social media, for example, to retrieve contents as evidence. And it's just a kind of interaction here. So it doesn't mean it changes the internet. It just interacts with the internet to extract the information it needs. Yeah. Hope that answers the question.
Thank you for the answer. Then we have another question coming from Maximilian. As I understand it, your method uses images. Using videos seems quite hard. Are there models that work well with them?
So, excellent question regarding that. So, indeed, DEFAME does support only images, no videos yet, and this is also a strong gap in the research community. So there are a few methods that or a few scientific works which target video fact checking. However, the number is very limited, and they're also pretty limited in their capability because they were mostly released until like last year, where also the large language models were not very well able to handle videos actually at all, because video processing requires a lot of processing resources, meaning that a video itself, depending also on the length, consists of thousands or tens or hundreds of thousands of tokens, and they need to be and they create huge overhead in processing, and that's a matter of compute restrictions in that case. There are also approaches which sample frames from the video and use them then as images in the process down the line. In the end, however, many methods, also regarding methods that use images as input, they sometimes just translate the image into a text representation describing what's in the image. And with this step, you actually lose a lot of information, a lot of important information needed for the fact-checking process, especially if you want to compare images. It is much, much harder to do this with just the text representations instead of having the images directly and comparing them directly next to each other, and or also performing reverse image search. For that, you of course also need the image itself. But yeah, video is one also next logical step to be done here.
Amazing. Then we have one other question from Michael. What do you think of sync, OpenSync, ontology, common knowledge database, classical logic, and human filled?
Oh, you need to repeat that. That was a lot of at once.
That's all right. What do you think about sync, OpenSync?
Sync.
Yes.
OpenSync.
I'm not really sure how to pronounce it. CYC.
Okay, CYC.
Yes. Ontology,
Okay.
common knowledge database, classical logic, human filled.
Classical logical human field. So to be honest, this all doesn't really sound familiar to me. Maybe you can elaborate on that, or like the person who asked that. That would be.
Well, hi, can you hear me?
Yes, I can.
Well, then study this. Then, if you don't know, it's just I think the database of human extracted facts, knowledges, and so on. 40 years ago started currently.
So it's a database of verified information gathered by humans or whatever and aggregated.
Yes,
Yeah. Okay. Okay. Never heard of that one before, but giving this
open
information.
Wikipedia. It's interesting. I mean, that's the only such existing project worldwide, I think.
Sounds very.
Okay. Thanks.
Sounds very interesting, Michael. Thank you. Because we, of course, for evidence retrieval, we need to use credible sources for our fact checking, and this, of course, you can integrate as well. If it has an API, then implement it as an extra tool into the DEFAME system. This is fairly easily extendable. It's better. Also, however, the disadvantage of such databases is that they also sometimes need time to adapt to new situations or to get the information saved into the knowledge base coming from new events or rapid events happening, and therefore often in like rapid evolving events, say like the plane crash which happened recently in India, there you cannot use such knowledge bases to actually verify if that plane crash really happened like in the last 60 minutes and where it happened, etc. And this is therefore such knowledge bases are very good for more midterm, long-term information and not for short-term fresh information. But yeah, still a good extra because credible sources are scarce.
I think it's more, it's not like verified events database, which happen to not. I think it's more a common knowledge, facts about the world. I don't know.
Yes.
Kind of, trees have leaves, and the leaves are green. Maybe in summer they're green, and in winter. So more about knowledge about the world and well, not like media facts or whatever.
I see. Okay, yeah, I see. World knowledge is often already very well encoded in the large language models we use. In that case, it's most often sufficient to rely on that for general world knowledge. Still, if you want to have extra like to be on the safe side when it's sometimes not that clear for someone being world knowledge, then you can of course use that as extra reference. Yeah.
Thank you so much. I think we have time for one last question. And if you have other burning questions, Mark is certainly happy to answer them. So the last question for today would come from Hevan. I'm sorry if I butchered the name. I know that automated fact-checking pipeline needs to have several blocks. So how about having a complete automated agentic AI-based system on the individual blocks of pipeline? How do you see the recent popularity of agentic AI framework in terms of the whole automatic fact-checking pipelines?
Yeah, that's an excellent question. So the DEFAME system which we implemented, it's a kind of our own implementation of an agent. It does not use the lower level agent implementation which is given by OpenAI, for example, with GPT-5 or with other agentic systems. But yeah, of course, you can use such systems as a block, as an approach to perform fact-checking or to perform the subtasks of the fact-checking pipeline, from claim extraction to evidence retrieval to the final verdict prediction. However, the task of fact-checking overall is does benefit from more specialized approaches and also more specialized methods because, for example, yeah, how to say it? Fact-checking itself is a difficult procedure which requires quite deep research. Fact-checking journalists they use techniques and tricks to perform evidence retrieval for their work, and like off-the-shelf agents like given by OpenAI are not necessarily that powerful. So it always makes sense to specialize them in performing specific tasks like evidence retrieval, or also in the claim extraction, which we did not cover here at all. There also fine-tuning techniques could be useful to improve such systems. Or also the tools. The agent, of course, always also needs the right tool set to perform the fact checking. So you need to include deepfake detection and geolocation tools and localization and chronolocation tools. And so off-the-shelf agents are not enough, but if you adjust them sufficiently, then they could perform that task pretty well, I think.
Thank you very much for your knowledge that you're all sharing with us, and for the engagement in the chat. I'm really, really happy how that turned out. I think Heman has also a follow-up question in the chat. But for the sake of time, maybe you could have some private conversation. Oh, and we have someone who finally wants to say something.
Oh, yeah.
We have so feel free. One last comment.
Is it me?
Yes, it's you.
Okay, thanks so much. I just want to ask, Mark, also thank you so much for sharing your work and taking
You're
us
welcome.
through. So, would you say that, so for DFAME also, did you use existing models to check, or yeah, first
Yeah,
that.
so yes, so we used existing large language models for that. So specifically, we used in this case GPT-4o, which was the best performing large language model here. We also tested 4o mini. We tested also Llama models, open source models. And they did not perform as good as GPT-4o, but we saw that at least the Llama 4 models, they were able to close the gap, the performance gap to GPT-4o quite a lot compared to other open source models. So Llama is also not bad already.
Okay, so would you say, in order to assure or achieve 100% accuracy, it makes sense to start from scratch?
Do you mean but from scratch by actually pre-training one's own large language model?
Or a world model or an
Or a world
MLLM?
model? Yeah. I don't think this will be necessary. I think that already off-the-shelf large language models like GPT-4o, GPT-5 are already a very good basis to start off with, and to extend them with the needed tools, with a correct procedure to retrieve the evidence, etc. I think this is already good enough to work with.
Okay, why I asked this was because you said that Grok can do silly stuff. So I thought maybe who's to say that some other model can't do that sometimes. So, to always ensure that.
Yeah. The point with Grok, for example, is that Grok at least by the time back then, I don't know how it's now, at least back then, it did not use any web search actually to retrieve information before providing the answer. It just answered by using its parametric knowledge. And this parametric knowledge is subject to a knowledge cutoff. So each large language model has pre-training data which ends at a specific time in the past. And what happened after that specific time is not contained in the pre-training data, which means the model does not know what happened after that. And that's the case with Grok, where it provided silly answers because it did not retrieve credible evidence from the web. Yeah.
Thanks a lot.
Sure.
Then thanks again to the impressive audience. Thanks again to you, Mark, for this wonderful talk. And I see this is
You're
a very state-of-the-art topic that is concerning many of us. And I think we have some insights into which phalanges we still change and what is possible today already. Thank you so much. Thank you, everyone, for your time. And I hope to see you in the next AI Academy.